Hello guys and welcome to Diddle's community. In this video we'll talk about craters and how to procedurally generate them in Unity. A couple of days ago I was working on my latest project and realized I needed some kind of extraterrestrial terrain generation tool and thought, I could put a link to it in the video description. But then I realized I'd have to make a video about it. And here we are, craters. The first thing I've done is I've googled the real thing. I pretty much knew what I would have found because I used to play a lot of Kerbal Space Program, so I'm quite used to how they look. Anyway, after having a look at some pictures online, I wrote down the main features. The shape of a crater usually resembles that of a sphere sector. It's not a perfect hemisphere, because it's filled with what remains of the meteorite, or whatever it was before colliding. It also usually presents high rims, and sometimes a small bump in the center. So that's what we're gonna do. A squishable hemisphere surrounded by a rim with a bump in its center. We're gonna make a lot of them and drive on the final result. Let's first of all have a look at the maths. Imagine you have a plane, your terrain, that you can deform on its normal axis. You can only move certain points defined by couples of integers, because the resolution is finite. How can you deform it into a hemisphere? You should set each point to the right height to approximate one. Let's consider the section of the crater. What are the coordinates of a point on this shape? If we draw a couple of segments, we'll get a solution as easy as this one. But wait! This solution is not necessarily an integer, so we'll approximate it to the closest integer. This will indeed mess up a couple of things later, but we'll come to it. Alright, we should now set all of the points located inside of the equator to the right height. To do this, I chose to consider a very small circumference and increase the radius. Then set each point of those circumferences, or again, their closest integers, to the right height, or again, to their closest integers. This approach could, in theory, work as it is if the resolution was a massive number, but it would take an accordingly massive time, so instead we'll just set not only the points, but also their neighbors to the sphere point height. To do this in code, we'll loop through the inner circles, and each time we do, we also loop through all the points of the circumferences, using the angle as an iterator. To make the rim and the bump, we can set the internal and external circumferences to a different height. I made the bump side decrease, with the distance from the center, and I just set the height of the rim to a certain level. After doing this whole thing, this was the result. Pretty good, but also fairly rough. To solve this, I made a smoothing function that sets the point height to that of the average of the neighbors. I applied this script to a randomly generated terrain and made a function called makeItRain, which applies the crater function a certain number of times with random parameters. What do you think about it? Let me know in the comments. As always, the code is in the description and you can change it and use it however you like. Just make sure not to hurt anyone with it. Goodbye.